Prove that the coordinates of the centroid of the triangle whose vertices are x1, y1, x2, y2, x3, y3 are x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3. That is, we need to prove that the x coordinate of the centroid is x1 plus x2 plus x3 by 3 and the y coordinate of the centroid is y1 plus y2 plus y3 by 3. Also deduce that the medians of a triangle are concurrent. That is, they pass through the same point. So here we have a triangle ABC. Coordinates of A, x1, y1. Coordinates of B, x2, y2. Coordinates of C, x3, y3. AD is the median from the vertex A on the side BC. Clearly, D is the midpoint of BC. BE is the median from the vertex B on the side AC. Clearly, E is the midpoint of AC. CF is the median from the vertex C on the side AB. Clearly, F is the midpoint of AB. This is the point F. F is the midpoint of AB. This is the point D, this is the point E, and this is the point F. So, having assumed this, having assumed the coordinates of A, B and C, let's find the coordinates of the points D, E and F. Now, we know that D is the midpoint of BC. So, how do we find the coordinates of D? Using the midpoint formula. x2 plus x3 by 2. The sum of the x coordinates here, x2 plus x3 by 2 will be the x coordinate of D. And what about the y coordinate of D? The sum of the y coordinates, y2 plus y3 by 2 will be the y coordinate of D. What about the coordinates of E? The point E? E is the midpoint of AC. So we need to use the coordinates of A and C to find the coordinates of E. Again, by using the midpoint formula, x1 plus x3 by 2 will be the x coordinate of E. y1 plus y3 by 2 will be the y coordinate of E. Again, using the midpoint formula and using the vertices A and B, using the coordinates of the vertices A and B, let's find the coordinates of the point F. x1 plus x2 by 2 will be the x coordinate of the point F. y1 plus y2 by 2 will be the y coordinate of the point F. So since D, E and F are the midpoints of the sides BC, AC and AB respectively, we find the coordinates of D, E and F using the midpoint formula. Now let's take up the median AD. Let's find the coordinates of a point on this median AD which divides the median in the ratio 2:1. We're just trying to find the coordinates of some point on the median AD, that point which divides AD in the ratio 2:1. So see here, coordinates of a point dividing AD in the ratio 2:1. So see here, this is the median AD, this is the median AD, correct? So we're trying to find the coordinates of a point on the median AD that divides it in the ratio 2:1. So 2 parts, 1 part. From A to the point G is 2 parts, and from G to the point D is 1 part, meaning AG is to GD is 2:1. As of now, this is some point on the median AD. Now, how do we find the coordinates of that point? Using the section formula. mx2 plus nx1 by m plus n will give us the x coordinate of that point. My2 plus ny1 by m plus n will give you the y coordinate of that point. So now the ratio is 2:1. So see here, 2 into this x coordinate plus 1 into this x coordinate by 2 plus 1 will be the x coordinate of that point. And the y coordinate of the point, 2 into this y coordinate plus 1 into this y coordinate by 2 plus 1 will be the y coordinate of that point. So you can see it here. You can see it here. See here, 2 into this x coordinate plus 1 into this x coordinate by 1 plus 2 plus 1, and the y coordinate 1 into y1. You can do it both the ways. See, I started from here, 2 into the y coordinate here plus 1 into the y coordinate here by 1 plus 2, alright, will be the y coordinate of that point. Now what happens here? 2 and 2 gets cancelled, 2 and 2 gets cancelled. So when you work this, you get the x coordinate of the point is x1 plus x2 plus x3 by 3, and the y coordinate of the point is y1 plus y2 plus y3 by 3. So now these are the coordinates of some point on the median AD which divides the median AD in the ratio 2:1. From this vertex to that point is 2 parts. From that point to D is 1 part. Similarly, let's find the coordinates of a point on the median BE that divides the median BE in the ratio 2:1. That is, from B to that point 2 parts, and from that point to E 1 part. So you can see it here. So we are trying to find the coordinates of a point dividing the median BE in the ratio 2:1. So how do we do that? So where's the ratio 2:1? See here. This is the median BE, correct? So this is 2 parts. From the vertex to that point is 2 parts. From the point to E is 1 part. So see here, 2:1. This is the median BE. So 2 into this x coordinate plus 1 into the x coordinate here by 2 plus 1. I repeat, it's 2 here. So 2 into the x coordinate here plus 1 into the x coordinate here by 2 plus 1 will be the x coordinate of that point which divides B in the ratio 2:1. What about the y coordinate of that point? It will be 2 into the y coordinate here plus 1 into the y coordinate here by 2 plus 1. We are simply using the section formula. The ratio is 2:1. We are simply applying the section formula to find the coordinates of that point on BE which divides B in the ratio 2:1. So this is what we have. On applying the formula, this is what we'll have. And this again works to x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3. This is the x coordinate of that point on the median BE which divides BE in the ratio 2:1. And this is the y coordinate of that point on BE which divides B in the ratio 2:1. Now let's take up the median CF and find again the ratio of, let's take up the median CF and find the coordinates of that point which divides the median CF in the ratio 2:1. So see here, this is the median CF. I told you, from the vertex to that point 2 parts, from that point to F 1 part. The ratio should be applied like that. 2:1, not like this, 2:1, not like this. From the vertex, see, the median is CF. The median is CF. From the vertex C to that point, 2 parts. From the point to F, this is the point F, 1 part. So we are trying to find the coordinates of that point on the median CF, which divides the median in the ratio 2:1. Again by applying the section formula. Alright. So see here, this is two parts. This is one part. Let me just show you like this. See here, this should be clear. This is the median CF. Can we see it? CF is the median. These are the coordinates of C. These are the coordinates of F. And see, look at only this line segment CF. The ratio is 2:1. The ratio is 2:1. Apply the section formula to find the coordinates of that point. So 2 into the x coordinate. 2 into the x coordinate plus 1 into the x coordinate here by 2 plus 1 will be the x coordinate of that point. Again, 2 into the y coordinate here plus 1 into the y coordinate here. We need to use the coordinates of C and F. C and F. Alright, so I was telling you 2 into the y coordinate here plus 1 into the y coordinate here by 2 plus 1 will be the y coordinate of that point on CF that divides it in the ratio 2:1. So this is what we'll have. See here. The coordinates of a point dividing CF in the ratio 2:1. So you'll have to use a section formula, and when you work that you will get the same thing, x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3. So what do we observe? On all the three medians, when we tried to find the coordinates of a point that divides it in the ratio 2:1, we have the same coordinates in all the cases. See here, we have the same coordinates in all the three cases. So this means this point lies on all the three medians. This point lies on all the three medians. See, this is the address of a point that lies on the median AD, which divides AD in the ratio 2:1. This is the address of a point on the median BE that divides the median BE in the ratio 2:1. And this is the address of the point on CF that divides CF in the ratio 2:1. So you can see that the address is the same in all the three cases. So that means this point, that is the point given by this address, lies on all the three medians. How is that possible? That's possible only when the three medians pass through the same point. So this proves that the medians of a triangle are concurrent. That is, they pass through the same point. And the point of concurrence is called the centroid. So which means this is the coordinate of the centroid of the triangle. This is the x coordinate. This is the x coordinate of the centroid, and this is the y coordinate of the centroid. So that's what is the conclusion here. Thus the point having coordinates is common to AD, B and CF and divides them in the ratio 2:1. Hence, medians of a triangle are concurrent, and the coordinates of the centroid. Centroid is a point of concurrence of the medians, and the coordinates of the centroid are x1 plus x2 plus x3 by 3, which is the x coordinate of the centroid, y1 plus y2 plus y3 by 3, which is the y coordinate of the centroid.